So hi and hello there, welcome to the new video of the course, and in this particular video we are going to learn the very first topic or the very first concept, that is slope of a line. So let me write over here slope of a straight line. Slope of line, I will write slope of a line because anyhow we are dealing with straight line, so inherently you should assume that we would be studying about straight line. What are the concept that we are going to study henceforth? So that would be around straight line, right? So now, as we had seen in the previous video, that we would be dealing with two axes, that is x and y, as far as 2D plane is concerned. So in 2D plane you have x axis and this is y axis, right? So this is the 2D plane, and let me just write over here, this is the x axis, this is the y axis, and this is the origin. Okay, and now let's suppose if I am passing one line over here, passing one line through x and y axis in this way. Let's suppose if it is passing in this way, right? So how you are supposed to calculate the slope of this particular line? So basically, just a second, let me just decrease its thickness. Yeah, something like this. So basically, slope of line or slope is the rate of, or just a second, I will frame this particular sentence in this way so that it would be easy for you all guys to understand this particular thing. So let me write over here the rate of change of the rate of change of y with respect to x is known as what? Is known as slope. Is known as slope of line or slope in general, right? Just a second, let me write it properly so that whenever you will refer this particular PDF you should not get doubt in your mind, right? So that means what? I would write slope in this way, that is slope is equivalent to change in y, just a second, yeah, change in y divided by change in x, right? This is what we had learned through this particular definition of slope of line. Or I can also write this particular thing in this way, that is del of y. Del means nothing but change upon del of x, right? So now let's suppose over here, let's suppose if I'm considering these 2 points, maybe this one over here, this one point, and this would be the second point, right? And let me again draw one projections over here. Let's suppose this is the first projections, this is the second projection, right? All right, so as you can see over here, if you could see very clearly, just a second, this is nothing but del of y, right? And this is nothing but your del of x. Okay, and let's suppose these points are, I'm assuming these points to be let's suppose this point as x1 y1, that means, see over here, this point would be y1 and this point would be x1, right? So this particular point would be I'll write over here x1 comma y1. So this is the first point and this is the second point. I'm drawing it with rough hand. So let's suppose this is y2, right? And this is obviously this particular point, it is x2, right? So I will write this particular point as x2 comma y2. Okay, so now over here the slope for this particular line would be, see, it would be in this way, that is slope is equivalent to change in y. As you can see over here, that means the difference between 2 points of y. As you can see over here, the difference is y2 minus y1, that means y2 minus of y1 divided by x2 minus of x1. So this is the most important formula for slope, and generally slope is denoted by m. So slope, just a second, yeah, slope or m is equivalent to del of y upon del of x, right? Which is equivalent to y2 minus y1 upon x2 minus of x1. Okay, so I hope you understood up till here. Let me just highlight it and then we will proceed further. Just a second. Yeah, I may use this particular color. Yeah, so this is the exact formula for the slope of line. Okay, now moving to the next page. Just a second, let me again draw that particular, or what I will do, I'll just copy this particular diagram in the next page because I may require this particular diagram. Control C and let me move to this page, Control V. Alright. So students, now if you could remember, if you are good in trigonometry, or if you have a basic idea about trigonometry, so there we had learned one formula, that is, let's suppose just a second, what I will do, I will just move this particular thing over here. Yeah, that means let me just draw one arrow indicating that this x1 and y1, we are talking about these two particular points, right? And now if you could remember that we know tan theta. So tan theta is equivalent to opposite upon adjacent. What does that mean, sir? That means, let's suppose if this is your triangle, just a second, I'm drawing it with a rough hand. Please try to understand this particular part, right? And let's suppose if this is the angle theta, okay, this is your angle theta, right? So how you are supposed to write this? So now you will say, so for that, let's suppose, sir, this particular length is, let's suppose if it is A, right? If it is B, the hypotenuse is B, right? And let's suppose this particular side, the base side, it is C. So tan theta would be, opposite of theta, that means C. Over here the theta is present, or the angle, so side opposite to this particular angle, that is A, opposite upon adjacent side, that means C. I will say this is absolutely correct. So can we apply same logic over here? Now you will say, why sir, why we are applying same logic over here? My dear students, just now we said that, see, the slope is equivalent to change in y upon change in x, right? And let's suppose if I am taking one angle over here, okay, let me take certain different color, otherwise you will get confused because I am using this same color again and again. Okay, so let's suppose if I am taking angle as theta over here, it can be anything, right? As of now I don't know. So what would be tan theta for this particular triangle which has been formed over here? Just a second, let me just move this particular thing somewhere over here, right? Alright, so for this you will say, sir, for this again we are going to apply the same formula, that is tan theta is equivalent to del of y upon del of x, right? And we all know that del of y is nothing but y2 minus of y1 upon x2 minus of x1, right? That means what? Our tan theta is nothing but, it is m, that is equivalent to slope, m or slope, slope, m or slope, right? That means slope is equivalent to tan theta. I can also write this particular thing in this way. Just a second, I will write it somewhere over here, somewhere over below, over here maybe. Yeah, slope is also, slope is also known as m, okay, which is denoted by m, is equivalent to tan theta, right? And these both are equivalent to del of y upon del of x, which is equivalent to y2 minus of y1 upon x2 minus of x1. Okay, so now I hope your concept of slope has cleared. Okay, let me just highlight it and then we will proceed further. Just a second, let me just highlight this particular thing. Let me just move this particular box somewhere over here. Yeah, now it is absolutely fine. And now I hope that you understood the concept of slope. Okay, so now we will see certain things over here. Let me again draw x and y axis. Let me just draw that particular x and y axis to see certain things. So what I will do, I will just draw this x and y axis roughly. Okay, and what I will do, I'll just copy this particular thing, Control V. We'll move this particular thing somewhere over here. What we will do, we'll try to understand certain things or certain cases out of it. Control V, and now we will move this particular thing somewhere over here down below. This one somewhere over here, this one somewhere over here, right? All right. So now we will see certain things. Let's suppose if I'm drawing a straight line in this way. Let's suppose if I'm drawing a straight line maybe in this way. Okay, something like this. And now I'm asking you slope for this particular point. First of all, remember one thing, whenever you are drawing 2D plane, so you should mark x and y axis. This is the origin point. Okay, and now let's suppose if I'm asking slope for it. So students, what is the slope for it? Okay, now you will say, sir, as you can see over here, for slope we require del of y divided by del of x. Now you will say, sir, the y is not changing. That means what? Change in y is 0. That means what? Change in y is 0. Or else you can also say over here theta, we know that slope is equivalent to tan theta, right? And over here theta is equivalent to 0. I hope you are getting my point. 0 degree, and therefore slope would be equals to 0. Okay, this would be the first case, and the second case would be in this way. See, you know the formula for this, del of y upon del of x. Del of y is nothing but y2 minus y1, but over here if I am marking this particular point, okay, your initial point is also y1. Let's suppose your initial point is also y1, okay, and your final point is also y1 comma y1. Your x is changing, no doubt. Okay, no doubt your x is changing with respect to anything, but your y is not changing. Okay, so this is your initial point and this is your final point for y, right? That is not changing, and that's why if I'm writing it in this way, y1 minus y1, which is divided by y2 x2 minus x1, which is equivalent to 0. Why? Because these two terms are similar. You can also go with this way, it's up to you. Okay, and now let's suppose if I'm asking you students, what would be the slope for this particular line. Let me just draw this particular line somewhere over here. Yeah, let's suppose if I'm asking you, students, what is the slope for this particular line? Just a second. This is x-axis and this is y-axis, right? And this is origin. So now you will again say, sir, we know that slope is equivalent to del of y upon del of x. I will say absolutely correct. Now you will say, sir, here the y or the value of y is changing. As you can see, if our with respect to x, the y is changing, but the x is kept constant. Okay, that means what? If the initial value of x is, let's suppose, x1, after some time it would be again x1, like it is not changing only. So this, if this is the initial value, this would be the final value as well. Okay, because it is not changing. So I will say absolutely correct. That means what, sir? I should write this particular equation in this way, del of y divided by 0, and this pans out to be infinite or not defined or infinite, but I will prefer to write it as infinite. Okay, and the another method or the another way to write this particular thing is, see, slope is equivalent to tan theta, and here theta is what? Theta is equivalent to what? Theta is equivalent to 90 degree. As you can see over here, it is making an angle of 90 degree, and we all know that tan 90 degree is not defined. Okay, it's not defined, or in other words, it is infinite, right? So that's why the slope for this particular line is infinite. Okay, and now let's suppose if I'm taking this particular point in this way or line in this way. Alright, and let's suppose if I'm giving you this particular theta or the angle as theta is equivalent to 45 degree. Let's suppose if I'm giving you the angle as 45 degree. So now how you are supposed to write this particular thing? So now you will easily tell that, sir, we know that slope is equivalent to tan theta, which is equivalent to tan 45 degree, right? Tan 45 degree, and we all know that tan 45 is nothing but 1. So therefore the slope of line would be 1. So I will say that is absolutely correct. And again, as I always tell to you guys, you should always first mark x and y axis. So this is x, this is y, and this is origin. Okay. So now I hope that you understood this concept of slope. Okay. So thank you for listening this particular video, and I'm ending this particular video over here. Thank you.